Good afternoon. Today we are continuing on with that slope-intercept form. We are doing CO56. I can write the equation of a line in slope-intercept form given an equation in standard form. So before I get started, my goodness, I feel super loved because everybody is so close to me, but we're getting super squished up here and people are having a hard time seeing. Let's try to push back just a little Okay. I needed a little space to be able to walk up here. Okay, so CO56. I can write the equation of a line in that slope-intercept form, which is what? Y equals mx plus b. So we're going to be doing that same slope-intercept form, but this time we're going to be given an equation in standard form. So we're going to see how we do that slope-intercept form when we're given standard form. So just like there are many ways to describe a warm day, it's hot, it's sunny, it's summery, it's caliente, using other languages, Mr. Schultz. There are many ways to describe the graph of a line. So one way is the slope-intercept form, y equals mx plus b. Another way is the standard form. So we're going to learn that standard form and how we can go back and forth between the two different types of equations. It's telling us the same information, it just looks different. So our slope-intercept form, you should all be able to fill in y equals mx plus b. Our standard form is ax plus by equals c. So we can see that we still have that y and x in our forms. So what do you notice about the location of the x and the y between the slope-intercept and the standard form? They both have x's and y's in it, but what's different? So look at our two forms. What do we notice? Two people have found a difference. Who else can find a difference between the two different forms? Looking at our x and y, what do we notice that's different? What do you think, Harper? Okay. So it's not necessarily that the y here is an answer. We've got the equal sign. It doesn't matter, we can flip it and it wouldn't matter. We just need to balance them out. But what about the y and the x? Beckett?
X and y are in the equation for the standard form, and the y is like what it equals.
So the whole thing is the equation, but the x and the y are on the same side of the equal sign in the standard form, and they're on opposite sides in the slope-intercept form. So underneath the slope-intercept, we would put opposite sides of the equal sign. And under the standard form, it would be same side of the equal sign. So that's a big difference between our two forms of our equation there. So we need to think about steps to convert the equation from standard form into the slope-intercept form. How do you think we're going to do that? think about what we have done in the past, the objectives that we've done, where we've moved things, because we know we want to get it to the slope-intercept form. We want the x and the y on opposite sides of the equal sign. Have we ever done anything moving stuff to opposite sides of the equal sign? Eleanor? Opposite operations. Right, so we're going to be using those opposite operations. We're going to move the x term to the other side of the equal sign using opposite operations, which we have done before. We know how to do opposite operations. So we're using a previous objective to help us with our new objective. Step 2 is the new part. We're going to divide every term by the coefficient to the y. So let me tell you what that means. We need to know what all of the parts in our equation stand for. So when we talk about a coefficient, the coefficient is the number that's connected to our variable. We have x and y are our variables. The number connected to the variable is your coefficient. Our terms, we have ax's together, by is together, that's c. Those are our terms. So the coefficient is the number that's next to the variable. We know what a variable is. The term is all of it connected like that. If there is a number with no variable, does anybody know what that's called? The number with no variable next to it is the constant, because it doesn't change. We don't have a variable that we multiply by and change it. So those are some vocab words that we need to make sure we understand. So when we see something like divide every term by the coefficient, we need to know what a term is. We need to know what a coefficient is. So we have variable. The number in front of the variable is your coefficient. If we have a number with no variable, it is the constant. And they are all called the terms. So that ax is a term, the by is a term, and the c is a term. I don't know.
So just to be exact, the A's, B's, and C's are the numbers, and then the X's and the Y's are the terms.
In this equation, yes.
Okay.
All right, so let's scroll up and see how we use all of this information. So let's work through some together. We're going to rewrite each equation into the slope-intercept form. So we have it in standard form, ax plus by equals the c. And like Eleanor was pointing out, that capital A, capital B, capital C, those are the numbers. The x and the y are our variables. We want to turn this into y equals mx plus b. So what is our first step going to be? So think back to those 2 steps that we just wrote up. What's the first thing I should do? Claire?
Move the X by doing opposite operation.
Yeah, we need to move the x. With the x is the 6, so we're moving that whole term over. 6x we want to put on the opposite side of the equal sign. So is 6x positive or negative? positive. Positive, remember, would be what operation? Because there's not an actual operation in front of 6x. So what am I going to do? Am I going to add or subtract, David?
You're gonna subtract.
I'm going to subtract. Because it's positive, the opposite of positive is negative, and we've talked about how that negative is subtracted. So I'm going to subtract 6x from both sides. So that's going to leave me with 3y on this side. Now, we know that mx is at the beginning of our slope-intercept form. So we want to keep that x at the front side. So I'm going to say minus negative 6x, and then that 21 is a positive, so I'm going to say plus 21. So instead of adding it at the back, say 21 minus 6x, I'm going to shift that 6x to in front of the positive 21. Okay? Am I done? I've got the y on one side and I've got the x on the other side. Am I easy peasy lemon squeezy here? What do I have to do, Harper? What was step number 2? So what is the coefficient to the y? Vivi? The 3. So I need to divide each of my terms by 3. Because what I want is I want it to be just a y here. So if I divide 3 by 3, it brings me down to the 1. So I'm left with just y. This was multiplying. I'm doing that opposite operation to get the 3 to the other side. So instead of multiplying, I'm dividing. It's that same opposite operation. What is negative 6 divided by 3? Luke? Negative 2. And then I keep that x there. What is 21 divided by 3, Amala? 7. So it's still a positive 7. So it's negative 2x plus 7. So we're doing that same opposite operations, adding or subtracting, and then that dividing. So it's new, but not new, right? We're using what we already know to go from the standard form to that slope-intercept form. So let's look at 4x minus 5y equals 20. What should I do first? Christina? I'm going to subtract 4x because I want that x on the opposite side of the equal sign. So that leaves me, what would my new equation look like? Christina? Negative 4x what? Okay. Is that what other people wrote? I'm going to tell you there's a couple of oopses in here. Let's see if we can find some oopses. Harper. Why would it be negative 5y, Harper? Because we have that minus sign right in front of it. Remember, we can't take that away. Minus a number is the same as a negative number. So we can't lose that negative sign. So we moved that 4x over and we're left with minus 5y. So we look at that as negative 5y. Eleanor.
She put a negative.
Well, we subtracted 4x, subtract 4x. So remember that negative is that minus sign. So that was absolutely correct. Fallon.
Is the 20 supposed to be positive?
If we look at this 20, It's a positive 20, so we should add 20. This is why I love, love, love being able to fix things up, because we learn from that, right? Those are easy, simple mistakes that happen all the time. So I like it when we make those mistakes and we can fix them up. What's my next step? Luke,
Divide every term by the coefficient.
which is what?
You would, so, minus 5.
Yeah, that -5. I need to divide each term by -5. Okay, so remember what I talked about last week. What I'm writing on the board, I should see you writing on your paper, step by step. Even if you say, oh, Miss Gambino, I can do this in my head. This is mental math for me. I got it. Why do I want us to go step by step? Who remembers? Why are we going step by step, Hadley? Yeah, and I showed us that complicated math last week. Mr. Schultz said what you're going to be doing next year. And it is not mental math, friends. Okay, get in the habit of doing step by step. So next year, it's not gonna be an issue. You're used to doing it. So we are getting in that habit right now. All right, so what is my new equation going to be? David?
I'm just gonna start with y equals 4/5. That's positive 4/5 times x plus -4. No, -4.
So I'm gonna write what you first said. So you said plus -4. So -5 divided by -5 is a +1, so it's just y. -4/5 divided by -5, he was right, negative divided by a negative turns to a positive. So it's +4/5 x. You could leave it as that fraction, because remember that is our slope, that rise over the run, so we leave it as a fraction. And then at first he said plus -4. See how goofy that looks? With the plus and the negative right next to each other? And then I love that David caught himself. He went, wait, plus negative, that doesn't make sense. That doesn't flow. And he said, oh, wait, it's not plus negative. It would just be minus. Because that plus negative is the same as saying -4. If we really wanted to do plus a -4, you would have to put parentheses around it, so we could see the difference between the plus and the negative. Okay, but remember, we're practicing becoming those proper mathematicians. Proper math says we call plus a negative, we just call that minus. Would I mark it wrong on the test if you said plus negative? No, I wouldn't mark it wrong. But I do want us to really start practicing being proper mathematicians. All right, next one. -10x minus 3y equals -36. What's my first step? Hadley. So tell me what to do. Which is what operation? So I need to add 10x to each side. So what is my equation that I'm left with? What's my new equation if I add 10x to each side? Who can tell me what I'm left with? Do you know, Robbie? If I take away that -10x plus 10x, that zeroes out. So what's my y gonna be? If,
Oh,
if I zero this out, what do I start my equation with? Yeah, negative 3y. And what's that going to equal? So remember, we want to put it into the mx plus b, so we want to move that x to the front. So it's a plus 10, which is a positive 10x. And then negative 36 becomes a what, Robbie? Instead of negative, we say, no, we're not doing the opposite, minus, yes. So that negative turns into that minus. Okay? So when we zero this out, we're left with whatever operation is in front of that y. So this was a minus 3y, so it turns into a negative 3y. That negative 36 turns into a minus 36. What's my next step? Eleanor, divide what by negative 3? Divide all of my terms by negative 3. Because I want to get the y by itself. What is negative 3 divided by negative 3? A positive 1. So I have just y. 10 divided by negative 3 is what? Alan?
3.33.
So, remember we're working with slopes. Because right in front of the x is a slope. So do I want decimal slope? So what am I going to put there? Graham?
3 and 310.
Say that louder.
3 and 310.
Nope. Amala. I'm going to put it negative because I had a positive divided by a negative. And then remember, I just keep it as the fraction because that's my slope, rise over run. I don't want a decimal. I don't want a mixed number. I leave it as that improper fraction. Don't overcomplicate it. Just leave it as the fraction. If you can simplify it, then you simplify it, right? I could have called this negative 2 over 1. Is that rise over run? Both are acceptable answers. What's the last part? Y equals negative 10 over 3x. What? Claire?
Plus 12.
Plus 12. I love that Claire saw it was a negative divided by a negative, so that turns it positive. 36 divided by 3 is 12. Okay, so don't be overwhelmed by this. It's just one step at a time. Remember to divide all of the terms by the coefficient to y. So I went in green, and I did all 3 terms get divided by that coefficient. So often people will only divide the x by it, and they forget to divide that constant by it, and we get the wrong answer. Okay, we need to make sure to divide all 3 terms by that coefficient. Rewrite the equations in slope-intercept form. Then, we have to identify the slope and the y-intercept of the line. Show your work. This is showing our work. Okay, so if we look at our first slope-intercept form that we have here, y equals negative 2x plus 7, what is my slope? Christina? Yeah. This is my slope, because that's the m. Then what is my y-intercept? Remember, that's the b. The y-intercept would be 0, 7. That's the y-intercept. So where does it cross the y-axis? At 0, 7. So you have to make sure that you rewrite it into slope-intercept form, and then you identify, you label which one's the slope and which one's the y-intercept. So we have this page, and we have, let's look at our second page. It says rewrite the equations in slope-intercept form and then graph the equation. Guys, it's not doing anything we don't know how to do. Okay? So we're gonna rewrite it just like we rewrote it on the front page. So we are going to move our x over with opposite operations. So plus y leaves me with a y equals negative 2x plus 5. Ooh, this one's an easy one. Why is that an easy one? David?
We're already done.
Yeah, there's no coefficient that I have to divide through, because it's just a 1. So, whew, that one I didn't have to divide out. Now it says to graph it. What do I need to graph it? Vivi?
The slope and the y-intercept.
The slope and the y-intercept on the front. We were practicing saying this is my slope, this is my y-intercept. What is my slope of this line? David?
Negative 2 over 1.
Negative 2 over 1. What is my slope-intercept? Amala? 0.5. So remember, we've done this already. We know our slope, we know our y-intercept. So I'm going to take that y-intercept, 0.5. I'm going to do my slope of negative 2, so I go down 2 over 1, and I graph it. All things that we've been doing individually, now we're putting them together. We've done opposite operations. We found the slope. We found the y-intercept. We've graphed our line using the slope and the y-intercept. Now we're just doing it all together. So we're taking different objectives and putting them together into one. Any questions on how to do this? Questions on the second page, or we're feeling okay? All right, so just remind yourself, we've done each of these steps and other objectives. So you can always look back at previous objectives to remind yourself, wait, how do I use this to find the line again? You can look back, you can come ask me, you can check to see if you're doing it correctly during our work time, but I do want to give us work time. So if we have questions, I can go over that now, otherwise I'm just gonna let you work. And if you are watching this at home, I hope you're well, I hope to see you soon. Remember, we have con due on Thursday, packet number 10 due next week, Tuesday. So if you finish working with this, make sure you're working on some of our other math. Have a wonderful day.